problem published long ago by a gentleman by the name of Yufei Zhao. And the thing that struck me about this statement was this odd here. In other words, the first thing I noticed, it has to be an odd positive integer. And I go, what's so special about an odd number here? And it took me a while to understand why that's important. But what we have here is a set that can be constructed in this fashion. It's a set of all x's such that both x and x plus 1 are relatively prime to m. Okay? So in other words, if that set doesn't have anything in it, this is non-operational, right? So let's say S is the empty set, then you wouldn't have anything to do right here. There's no members of this set, so done. This statement is void of meaning. However, if S has elements in it, then the product of those elements is congruent to 1 mod n. So again, you may already see why this is true, but I just want to take a look at the case where n is even. It helps me to understand these conditions a little bit better. Let's say that we have n equals to 8. Okay, n equals 8. Okay, and I'm just going to pick a pair of numbers. We'll do x equal 3. All right, and then x plus 1 equals to 4, and that's in keeping with the letters used up here. Okay, so x plus 1 equals to 4. Now, again, I'm just using the exact same letters here. So what does this say? You get to be a member of this set if both x and x plus 1 are coprime, relatively prime. They said that in the old days. I think it's coprime. They share no common factors with n, right? Well, you'll notice here that that's certainly the case with x equals 3. 3, the GCD, or the greatest common divisor of 3 and 8, certainly equal to 1, right? Okay, but the GCD of 4 and 8, 4 being an even number, of course, here, is equal to 4, right? So you see the problem we have here, this kind of thing will always happen with any pair of x and x plus 1s that satisfy these conditions right here. So you're always going to have one of the numbers that's going to be even. And so you never, the set's empty because both x and x plus 1 can't be relatively prime. Now, I've just shown you one example of this. I've just shown you one example. But because of the nature, you know, a number is either even or odd, you're never going to, it's never going to work out for you. In other words, S is always going to be empty. And again, I've just shown you one example here, but S is always going to be empty in the case that the moduli is even. All right, so I thought it was kind of interesting all by itself, and it was a homework problem, and this was just stated, but to me it's worth mentioning that the moduli has to be odd for the problem to even work. Hope you enjoyed it. I want to prove this in general. I don't know how to prove it in general. I've worked through a lot of special cases, but I still haven't been able to prove the thing in a general sort of sense. I'm sure it's an easy proof. But anyway, that's it for tonight.